My name is Shrivant Reddy, and this is my Lab 5 presentation. Just as an introduction, the goal of our experiment was to determine if there was a difference between the distribution of energy between theoretical and practical data, theoretical and practical determinations. We were mainly focusing on momentum and energy as our main focus as we were working with collisions. We used two cars, one stationary and one moving, and we saw the energy transfer between the two, and we had to determine the initial and final velocities of each, as well as the energy transfer to the system. We made sure that no work was being done on the system and that car one started with the initial velocity, and we used Tracker to collect all the data. Just here's a quick video of how it looked like. So you can see one car was stationary, other was moving, collided with the one car. The other car stopped moving, and the car that initially got collided into started moving. So as you can see, that was our experiment, how we set it up. Uh, So, just as set a few initial conditions, we said that there were two cars with the same mass, x distance apart. The surface is frictionless. Car 1 approaches car 2 in an x direction with an initial velocity of 0.159 meters per second, while car 2 remains stationary. After collision, car 1 becomes motionless. So, just as a quick clarification, the initial velocity is also the constant velocity. So that means there's no force acting upon it, assuming this is frictionless in like a chamber, a test chamber of sorts. And just with a quick few calculations, we saw that the final velocity was equal to initial velocity. So the initial velocity of the second car was equal to the initial velocity of the first car after the collision. And then we compared that to the actual data, and we saw that the actual initial velocity was 0.132, while the final velocity of our calculated data was 0.159 meters per second. So, calculating kinetic energy difference, we saw that there was some energy difference the between the actual data and what we calculated. So, what does this mean? Well, that means that our calculations assume that all energy was perfectly transferred in the process of the collision. However, that is not the reality of any case, most of our cases, because as collisions happen in the real world, kinetic energy is not the only thing being transferred. There's also things like like sound, all these different factors that you have to consider. And because we only considered momentum and velocity and the movement of the objects, we did not perfectly reflect the environment, and therefore we can safely say that um, calculations done on paper do not as accurately reflect what's recorded outside in the real world. And just as a note, as we add more variables into our calculations, as we calculate the final amount, the F net energy, we'll see that we get more and more closer to the actual net energy in our resulting experiment. Just as a few possible errors, some of the errors that we could have encountered was like air resistance, unwanted air resistance, some unwanted friction. We said that it was frictionless and it was close to frictionless, but might have not been completely frictionless. And we also might have had some tracker errors. We might have tracked some data like poorly, or the tracker might have not picked up some stuff. So yeah, that's all. Thank you.